forms of electricity that we use every day: DC or direct current, AC or alternating current. What is the difference between the types of currents? Consider subscribing to Electrical Engineering Planet channel to support our community. In electricity, we have two different forms of current. The first type is DC or direct current. Here, the current is unidirectional, which goes only in one way, from positive terminal of a source to the negative terminal through the circuit. As you can see here, we will connect a DC voltage source or a battery to a lamp, then turn on the switch. Here, the current will start to flow through the circuit in one direction, and it will keep cycling. This DC was discovered by Thomas Edison, which tries to use the DC empowering towns and houses. The second form of current is AC or alternating current, which was discovered by Nikola Tesla. As you can see, if you connect a lamp to an AC source, then turn on the switch. Here, the current will be bidirectional, which alternates back and forth in a sinusoidal form. It increases with time until it reaches to the peak point. Then it decreases again with time until zero. At this point, it will reverse the direction, and it will increase in the negative value until it reaches to the peak point. Then it will decrease to zero again. Then it will reverse the direction to the positive value again, and so on, and it will keep repeating itself. This is called a cycle. Here, a new term will appear, which is frequency. Frequency means how many repeated cycles in 1 second. In my country, I have 50 Hz power source, which means that these cycles will repeat itself 50 times in 1 second. As you can see here, the lamp will start to glow brighter as the current increases. Then it will start dimming as the current decreases until zero, which will cause no light at all. We don't see this happens because our slow human eyes cannot notice this process, which is very fast, 100 times of on and off every single second. What we will see is a constant light. But if we decrease the frequency to a certain level, we will start noticing what is happening with the lamp. For example, at frequency equal to 1 Hz, only one cycle with 2 peak points will occur. So, as a recap here, DC is a unidirectional voltage or current which flows only in one way. But AC is a bidirectional voltage or current which alternates back and forth every half cycle. DC, current or voltage could be constant or could be changes with time in the same direction. AC have 3 waveforms: square wave, triangle wave, and sinusoidal wave, like our homes. The frequency of direct current is 0 because here we don't have repeated cycles. In AC, we have frequency, maybe 50 Hz or 60 Hz. In AC, we have power factor, which change between 0 to 1 depending on the load. You can watch the video of power factor in the description down below. In DC, power factor is always equal to 1. So in DC, we have only resistive load, but in AC, we have resistive, inductive, and capacitive load. The applications of AC in our homes are lamps, compressor of AC, water pump motor, and more. The applications of DC are laptop, cell phones, electric vehicles, flashlights, and any electronic device. So to charge your laptop or your mobile, or to supply DC to any electronic device, you need a converter, which convert the AC power supply exists on your home receptacles to DC. To convert DC to AC, you need an inverter. In the next video, we will discover the components of medium voltage power transformers. You can check the resources in the description down below. Consider subscribing to Electrical Engineering Planet channel. Also, don't forget to share